Good morning. I'm pleased to be the first speaker today talking about the future of Move and Aptos. Just a quick show of hands. Which of you have heard of Move? Good to see that Move is making its way through Asia. We're really excited about what we've done as an industry and as what we've done as a company to bring Move forward into the future. Just a little bit of a history. I was at Meta for 10 years before this. A long portion of that time was spent building data infrastructure for scalable systems, and the last 3 years I spent working on DM, which you may have heard of as well. And as a part of the DM project, we really try to take an interesting approach about how do we scale this blockchain infrastructure to not just tens of millions of people, but to billions of people that were using the Meta platforms. So I'm going to walk through that now. Let's see, this clicker, Going back to the mission, it's really about how do you build a worldwide public utility for everyone? Everyone can participate in it. It's permissionless. It's owned by everyone who uses it. And it's something that operates very similar to the cloud. It scales infinitely with your use case. It supports security for all the customers. And you can build any kind of applications that are composable across different industries, whether it's going to be DeFi, it's traditional media entertainment, as well as gaming, and everything else that comes up in the future. Going to our technology stack, we really want to take fundamentally a look at what we could do to change the way infrastructure was built. We were excited by technologies like Bitcoin and Ethereum, but we felt that stack would not support the needs of billions of people going forward in the future. And so we focused on a couple of key concepts. The first being parallelism. How do we execute as many transactions in parallel as possible in the stack? Pipelining. Taking a look at modern CPU design, superscalar infrastructure, we see the way that staging out these different portions of the execution, whether it's kind of the early parts of dissemination or execution and consensus are split in different pieces, as well as how do you kind of bring the sub-second latency that's required for internet applications today that we see in everyday products like Amazon, YouTube, Netflix, and others. And thinking about then how do you take that design and put it into an infrastructure that is permissionless and decentralized. And we came up with this interesting design, which was about breaking the architecture of transaction execution into 5 different stages. The first stage is parallel transaction dissemination. Any validator can receive transactions. Every validator then blocks those transactions and sends those to other validators to get what's called a proof of availability. This means there's no single point of failure and no issues when it comes to things like you've seen today, where a single leader might get bombarded by a set of transactions, whether it's meme coins or other types of workload that we see in modern systems. The next step is that we have something called block metadata ordering. We have the fastest consensus protocol built in Aptos BFT, and we've been developing something called Shoal, which is a next generation consensus protocol that combines high throughput and all the advantages of leader-based selection and reputation in practical PFT protocols. The next step is that we execute with parallel execution going forward. Every single infrastructure today has been mostly sequential execution, except for a couple, Solana, Say, and Aptos, and a couple others. What's different about Aptos, though, is the way we do parallel execution. We use dynamic concurrency techniques. If you're familiar with databases, there's something called optimistic concurrency, where you try to execute as many transactions as you can in different kinds of execution pipelines, and then resolve conflicts only at runtime. This kind of runtime parallelism is actually the most concurrent possible. And then you may have heard of static execution as well. That's a different kind of parallelism. That one is where developers need to declare those dependencies up front, and it's a little bit harder to make composable applications going forward with that. Not only that, certain applications, like when you think about how do you build a central limit order book, are impossible to parallelize compared to what we can do in Aptos. The fourth phase of execution is around parallel batch storage, making sure that you take advantage of SSDs to write in larger operations with fewer IOs and seeks. And finally, state-proof certification, where you have these authenticated data structures which are generated periodically for light clients. Anyone from a mobile device or from a phone can verify the state of those transactions as well as the history of the transactions as well. And what's really cool is that all these stages, while they are a pipeline, work completely in parallel. So we're always producing blocks that are being sent to ordering. We're always executing those transactions in parallel, and we're always continuing to generate those proofs as well. And this allows us to be able to take any kind of number of resources that are available to the machine, whether it's more CPUs, more memory, more networking, or even over time, sharding that execution across multiple machines, take advantage of more and more throughput going forward. And what we've seen is that this can produce amazing, incredible results. One thing we do periodically is we produce something called PreviewNet, where a bunch of nodes, node operators, and the Aptos teams get together and run experiments over the next generation of the software. We do this because there's a lot of hype out there, there's a lot of numbers out there, but what we want to do is produce benchmarks that are both verifiable and reproducible for anyone in the infrastructure to build out with. If you're familiar with databases, you may be familiar with something called TPC benchmarks. Our industry desperately needs benchmarks like this to understand how do different workloads perform in different systems. We've taken the first step to actually produce those benchmarks. If you go to the Aptos Foundation website, you'll actually see a long history of those benchmarks being run, as well as how you can execute those for yourself on your own infrastructure. And what we've seen is that if you take that exact mainnet setup that we have in Aptos, replicate it and mirror it, we can see over 30,000 transactions per second at peak. And the way we do this is we have that sharded storage coming into RocksDB instances. We have several improvements to the way that we increase our block space, as well as optimizations to the network stack as well. Now, having that run for 30 minutes or so is great. But a long question is also, like, what can you do with sustained demand for block space in the infrastructure? And so we also ran those experiments for a longer period of time, for 24 hours. We saw that we could do more than 2 billion transactions in a 24-hour period. And just for comparison, VisaNet does about 150 million transactions in a day. And so this means that Aptos can actually support more than 13 times what VisaNet can do in its current setup and current hardware requirements. Obviously, this is just a stepping stone, and we can do much, much more in the future. But we're really happy where we are today to show that blockchain can actually do much better than traditional systems. The last benchmark I want to talk about is also very interesting. When you generate and mint NFTs, everyone thinks it's a sequential operation. You have NFT 0, NFT 1, NFT 2, NFT 3, go on and so forth. And traditionally, this has been very, very slow. What we've been able to explore in Aptos is a technology called aggregators. Aggregators are a way for certain types of operations, which are both commutative and associative, to perform most of the operation up front in parallel, and then only at the last part, kind of assign those indexes at the end. This allows us to effectively parallelize what is sequential going forward. And that allowed us to get more than a million NFTs indexed in less than 90 seconds. The great thing about building super scalable technology is that it allows us to work with the largest enterprises in the world. So just to highlight a couple partnerships, we've been working with Microsoft on AI initiatives, Web3, as well as financial services infrastructure. Some of the products we built include Aptos Assistant. We've also been dumbing something called Find Out together. And we're starting to explore what the future of finance could be with respect to AI as well. We've partnered with companies like NBC Universal on projects like Renfield, as well as The Exorcist, to think about different ways of fan engagement that scales to millions of people that watch those content. We're also working very closely with a lot of numbers of partners in Asia as well. SK Telecom has built an Aptos wallet for mass adoption, and Lotte is exploring how retail applications, as well as NFTs, can really interest the community of shoppers and users in that platform. And for those of you who have been starting to play with Move, and we see the audience being very engaged here, Move is really growing rapidly. Aptos is already the #1 Move community in the ecosystem, and we see that the developer numbers speak for themselves. Also, by non-EVM daily active addresses, Aptos is right up there, and #1 essentially for the Move ecosystem. And so it's growing really quickly, and we expect that as people start to understand the transitional effects of Move, how it makes your application safer from the beginning, how you're able to develop faster and get from ideation to production, these numbers will only increase over time. It's not just about Move, though. It's really about the idea of how do you have control over a full stack. Many of you are familiar with the modular thesis and the integrated thesis. What we're here to talk about is that it's less about a thesis in this space, but rather how can you build a software stack that supports the use case best for what you're trying to accomplish. In our case, we have several goals. We want to make sure you have security for smart contracts. This is where taking advantage of Move, the Move prover, and being able to formally verify security properties of the Aptos framework are really a differentiator in this space. Imagine that you can actually formally verify your DeFi apps as well. Having this composition of formal layers of security and then making sure that you can leverage the composability of security across those layers is something that's going to change the way we think about the DeFi infrastructure going forward. And not only supporting DeFi, but also open financial stacks where traditional players come in through real-world assets and other tools going forward. The other thing great about having full control over the stack is that you get parallelism at every level of the stack. Things like aggregators, which I just talked about earlier, are impossible unless you kind of have the ability to change the way the VM works, change the way the consensus protocol works, as well as the execution stack and the pipeline framework. Being able to push different pieces to different parts of the stack gives us the full control to build freely. The way we also kind of like to describe this is, if you want to make a Ferrari, it's really hard to take car parts from Toyota, from Lexus, and from Mercedes, and build that super optimized vehicle. Being able to select everything from the way you think about the design, to the way the bumpers are put on, to the tires, to the way the weight balancing happens, is really, really important to build a super streamlined vehicle for your use case. The other thing is that we have account abstraction natively built in because of the way that Move and Aptos work together. This means you support multi-sigs, sponsored transactions, as well as crypto agility. And probably the most important aspect of this is that we have a super fast development cycle. Being able to develop for a single stack, testing everything fully, and being able to look at the use cases of not having to think about, like, I'm combining this stack and this stack together over this bridge, and what happens in these use cases allows us to iterate much, much quicker as a team and produce these innovations that come to market much faster. Today I'm going to walk through a couple of the next-gen developer experience things that we're building across core infrastructure, developer platform, and blockchain infrastructure. The first thing is, if you want to onboard more than 5 billion internet users today with the best UX on any device, we want to make sure that the inner experiences that we have are available for blockchain. So the first thing we've been working on is something called Aptos Keyless. Aptos Keyless provides a way to have a non-custodial social login using a zero-knowledge proof to tie to your blockchain-based account. So any OpenID platform, whether it's Google, Facebook, or others, you can log in with just 2 clicks into your application. And this allows you to create apps on mobile devices, on desktop applications, in games, anywhere you'd like, and have it really, really easy to log in, as well as authorize those transactions. The second thing is passkeys. Many of you today use your phones. I see a couple of you on them today, right now. And you can log in with them, your Face ID. You can log with them with your Touch ID. And being able to log in with your app, to your blockchain-based account, as well as sign those transactions directly because you have the web authenticator built directly into the Aptos blockchain, is a game changer when it comes to that user experience. The third thing we've been working on is a web wallet. So right now, a lot of you use Chrome extensions. You use mobile apps as well to log into your account. It's great to be able to just go to a web page, use your social login with Keyless, and be able to transact immediately without having to go through the trouble and the pain of getting started with the downloads. We've also thought a lot about how do we onboard new Move developers. We have a new developer portal coming on. We have a token platform we're designing, as well as NFT tooling. But maybe the part I want to focus on the best here is high-performance indexing. Indexing is something that a lot of people don't talk about, but is really important for dApps being built today. As you think about building a dApp, your first thought is, who's going to host a full node infrastructure? Who's going to host the indexing services for you? How will I support this very, very high throughput for my new application as it grows over time? And something that Aptos is continuing to produce is indexing infrastructure where people can plug in their own custom indexers into it. And this allows both infrastructure providers as well as users to customly use that for you. Being a high throughput blockchain requires very high performance indexing as well. And we're building out a very scalable solution to support those high indexing needs. On the developer platform side, we've been working on a lot of educational resources for how do you pick up Move. We have Aptos Learn, where you can take a look at Aptogachis, which is a fun play on Tamagotchis for those of you who are old enough as me to remember that. You can build and create your own content and have an end-to-end dApp, not just Move contracts, but front-end as well, to explore the Move ecosystem. We're also building out over to other tutorials as well that incorporate features such as randomness going forward. You should check out our new developer website. It also includes many different ways to think about Move development coming from other ecosystems. We have a guide for those familiar with Rust or familiar with the EVM stack to mapping those concepts into Move. And how does it make sense in the Aptos space? There's also a ton of framework upgrades. So framework is kind of like the standard library of Aptos. We have new account caption features coming where you can do custom authentication fees. And there's also a full developer tool suite being built out. So those of you who love to build, with Python, C++, and every other general purpose language are very familiar with taking advantage of VS Code, IntelliJ, and others. And you're able to do the same things within Move. We have analyzers, formatters, linters, all with IDE plugins to give you a great developer experience. We also go a level deeper into Move. We've been extending the Move language itself with many different features, including enums, public structs. We've also been exploring something called resource access control, where you can enable parallelism hints at the execution engine. This means that you don't need to do as a programmer, but will automatically infer the information you're accessing and use that information to actually optimize for your transactions, reducing fees as well as increasing concurrency at a very low level. Move itself is a language that is young. It was kind of developed starting in 2018 and not really tried and tested until Aptos was deployed until 2022. We are actually pushing the boundaries here with the next-gen Move compiler, which makes it much easier for us to take advantage of things like the Move prover, as well as extend new features well into the future quickly. The second thing we're doing is also building out the Move VM. Our next generation of the Move VM is going to take advantage of many different techniques such as caching, parallelized runtime loading of modules, and also have new features available such as debugging. And this Move VM is something that's going to really change the game in terms of performance as well as usability. On the blockchain infrastructure side, we're proud to announce that we developed the first secure on-chain randomness primitives that are available for any application and any use case for every block. And this use case the use case for secure on-chain randomness might be the best use case of blockchain we've seen so far yet. Finding a true source of entropy is very, very hard. And being able to build a very fair and robust online casino or a very fair lottery system is something that can only be done in Aptos today. Leveraging the same kind of primitives you're used to, generating random numbers from a range or from an integer, you can imagine very, very exciting applications of space. We've had more than 75 different teams participating in the random hack. And we'll be announcing soon a lot of their applications they've been creating, but they're a lot of fun, and they can only be done on Aptos. On the blockchain infrastructure level, we've been working on the keyless accounts. That's the accounts in the back end that then tie using zero knowledge proof to your OpenID login. We've also been working on aggregators, but I want to talk about storage sharding. So being able to support those multiple storage instances per elevator to increase throughput, we are the first network to do this in production. This allows us to scale out the IOPS and the storage space to solve the state bloat problem. We're never done with consensus. We've actually iterated 4 times on our consensus protocol so far. Shoal Plus is going to be our 5th iteration. It is the first high throughput DAG paired with the benefits of leader reputation and pipeline consensus to go live. We've been testing this in our latest preview net. You can take a look at the archive, the paper that just published at FC this year. It's truly a game changer when it comes to performance. When it comes to testing, we do take this very, very seriously. A lot of our work has been to develop these benchmarks and to develop these standards which we can use to evaluate blockchains across every type of application and every type of use case. And in doing this, we have a preview net we've been running, preview net infrastructure we've been running kind of continuously. We have mainnets. We've been developing a benchmark suite, which takes into account peer-to-peer type transactions, cryptography operations, sponsor transactions, and we'll be including DeFi transactions as well going forward in the future. We hope this kind of standard in templating for benchmarks will be used across other blockchains so we can start to compare their characteristics and their performance. And just to sum it up, there's a lot going on in Aptos in 2024. We're really, really excited about the fact that we can iterate very quickly in our space. Upgradability is a core functionality of the Aptos blockchain framework, and we've done this through 40+ AIPs in the last year and a half. You should expect a lot of changes going forward for not only Aptos, but for our industry, and we want to be at the forefront of it. So just in summary, Move in Aptos is changing the way we think about next generation infrastructure for Web3. We'll start to see more and more of those use cases coming into our area as we enable what the infrastructure can support. Internet user experience is going to improve greatly. With technologies like keyless, passkeys, and others that enable our current internet experiences, we'll see those on blockchain in Aptos, and we'll see those start to change the way we think about application building in the future. Aptos itself has demonstrated unmatched scalability and performance through our verifiable benchmarks in things like PreviewNet. We hope to keep pushing the envelope here, whether it's going to be 100,000 or 1 million TPS in the future. We're working really, really hard to onboard folks with Move. Move is a game changer when it comes to safety and developer time to market. And rapid innovation is our core thesis. We want to continue to move the needle here because infrastructure is not yet ready, but it will be ready for the 5 billion internet users in the very near term. And we think ultimately this will lead us to mass adoption. And with this, this concludes my talk. Thank you very much.